You've probably seen the headlines, right? Have you ever wondered why some of the most advanced engineering projects on the planet keep violently collapsing in the Himalayas? We're talking about massive subterranean floods, sudden rock bursts, and terrifying cave-ins that are claiming lives and setting back infrastructure by years. We tend to think of mountains as these solid, immovable blocks of stone, but what if we're actually trying to punch holes through a living, breathing, and highly pressurized geological giant?
Welcome to this explainer. Today, we're zeroing in on a massive issue: the sinking of Joshimath and Silkyara and the fragile geology that engineers tried to ignore. We're going to unpack the terrifying reality of these recent subterranean disasters and explore this absolute clash between our ambitious infrastructure goals and the unpredictable, fragile geology of the Himalayas. It's a reality that, unfortunately, conventional engineering has tried to sidestep for far too long.
Here's how we're breaking it down today. First, we'll look at the Himalayan collapse epidemic, followed by the fragile geology and hidden water threats. Then, we'll dive into the ignored warning signs, the blueprint for resilient tunneling, and finally, what a safer Himalayan future actually looks like.
All right, let's jump straight into part 1, the Himalayan collapse epidemic, a sequence of tragic failures.
Look, it's absolutely crucial to understand that the recent disasters we keep seeing in the news, they aren't just isolated flukes. They're part of a growing, deadly epidemic across the entire Himalayan fold and thrust belt. Now, this region has seen at least 16 major disasters since 1894, but the frequency of these infrastructure collapses is accelerating fast. Just tracing the recent timeline, in 2021, an unbelievable 27 million cubic meters of rock and glacier ice collapsed in Chamoli, wiping out 2 hydropower projects. Then, in 2023, we all watched that tense 17-day rescue mission when 41 workers were trapped inside the Silkyara tunnel. By 2025, the SLBC Tunnel 1 suffered a massive collapse that completely submerged a tunnel boring machine. And just recently, in the summer of 2026, we saw an aquifer burst in Chamoli and a massive explosion at the Teesta Stage 6 project. The pace of these events is literally off the charts.
To put the human cost into perspective, just look at this number: 25. That is a staggering number of workers who tragically lost their lives in the July 2026 methane explosion inside the Teesta Stage 6 project in Sikkim. These aren't just minor engineering setbacks, they are profound human tragedies that demand a total shift in how we build in the mountains. Which brings us to part 2, inside the fragile geology. It's essentially the living mountain versus concrete. So, to understand why this is happening, we have to look at how we build. Conventional engineering assumes rock is just dead, static material. But the Himalayas? They're a young, dynamic, seismically active system. It's truly a living mountain. As tectonic plates collide, they create these major faults, like the main central thrust. And right near these faults, we find what are called shear zones. In these zones, the rock is heavily crushed and foliated, meaning it's split into thin, incredibly weak layers. So when tunnels like Silkyara cut right through these highly deformed shear zones, engineers aren't boring through solid bedrock. They are basically trying to excavate through a pile of fractured rubble.
This incredibly volatile environment leads to what geotechnical experts call EGOs, or extraordinary geological occurrences. We're talking completely unforeseen anomalies, sudden deep shear zones, and something called squeezing ground. This is where the immense weight of the mountain above actually causes the tunnel walls to deform and violently close in on themselves. Dealing with EGOs means tunneling in the Himalayas is just a whole different ballgame and way more dangerous than your standard rock excavation.
Let's move to part 3, the hidden water threat. We're talking about subterranean oceans trapped right in the rock.
Beyond the crushed rock, the second massive surprise that engineers routinely underestimate is the highly pressurized underground water architecture. The Himalayas literally store vast amounts of fresh water in subterranean oceans, trapped within that fractured rock. When a drill breaches one of these hidden reservoirs, it triggers an aquifer burst. The result is instantaneous and totally terrifying. In August 2026, at the Vishnugad Project, a rain-saturated aquifer ruptured right through the roof of a tunnel. Surviving workers describe this violent gust of air followed immediately by rising water and debris, chest deep, which tragically took 7 lives. It's exactly like a subterranean dam breach.
To really wrap your head around the sheer volume of water we're dealing with, think about this number: 600. Back in 2009, during the Tapovan project, a tunnel boring machine punctured an aquifer 900 meters below the surface. That single tiny puncture released 600 to 700 liters of water every single second, for months. That is enough to completely dry up the local hill springs. we are fundamentally altering the mountain's internal plumbing.
So, why are we continually surprised by this? Part 4. Ignoring the warning signs, policy workarounds, and overlooked science.
The blunt truth is that flawed engineering assumptions, super aggressive construction timelines, and simple human decisions are overriding geological realities. There's a massive disconnect here. Conventional models, which are often used by contractors from outside the region, assume the rock is stable, dry, and inert. But as we've seen, the Himalayan reality is active thrust faults, highly pressurized aquifers, and squeezing ground. Treating these dynamic mountains like static blocks of concrete is a fatally flawed assumption. It leads directly to structural cracking and severe land subsidence, exactly like the sinking we've seen in the town of Joshimath.
And the regulatory approach hasn't exactly helped mitigate these risks either. Reports show that the massive Char Dham road widening and tunneling project was strategically divided into 53 smaller segments. By doing this, the project effectively bypassed the requirement for comprehensive, project-wide environmental impact assessments. Neutrally speaking, without those thorough, wide-scale geological evaluations in place, critical vulnerabilities just remained completely unseen until it was too late. Geologist Navin Juel sums up the whole problem perfectly, saying, "If you're tunneling in the Himalaya, you're in for two surprises: water and shear zones." Experts have continuously warned that altering these subterranean drainage paths without doing proper hydrogeological studies is a total recipe for disaster. Yet, time and again, these warnings have been sidelined in the rush to get infrastructure projects over the finish line.
But there is a way forward. Part 5. Blueprint for Resilient Tunneling. It's all about adapting to the mountain.
This string of recent disasters has finally triggered a massive wake-up call for the industry, forcing a shift toward resilient methodologies that adapt to the mountain, rather than trying to fight it. Look at this shift. The old method of just using sparse surface boreholes is being replaced by aerial electromagnetic surveys that can actually map the deep hydrology from above. Those rigid fixed-price contracts that kind of disincentivize safety, they are shifting toward equitable risk-sharing frameworks so contractors don't feel pressured to hide geological surprises. And instead of scrambling and reactive rescue operations, we're moving to real-time monitoring and early warning systems, with live data feeding directly from the tunnel face.
Which leads us to our final section, Part 6, A Safer Himalayan Future, New Guidelines and Government Mandates.
Following the massive public outcry over Silkyara and the other incidents, the government actually stepped in to fundamentally overhaul how underground infrastructure is executed. Under the newly issued National Tunnel Safety Guidelines, there are now 4 clear mandates. First, comprehensive hydrogeological studies are strictly required to map out hidden aquifers. Second, geotechnical baseline reports have to be integrated so everyone has a shared understanding of the ground conditions. Third, projects must maintain active risk registers to continually classify collapse zones as they dig. And finally, continuous real-time monitoring is now mandatory. This is a monumental shift from a speed-driven culture to a strict safety-first approach aimed at protecting workers' lives.
So, what's the big takeaway here? We absolutely must respect the mountain's hydrology. A tunnel isn't just a hole in inert rock. It is a passage through a fragile, living ecosystem. True engineering resilience isn't about overpowering nature, it's about anticipating its immense power and building in harmony with it. If you found this update helpful, please hit the like button and share this video with fellow members. For more deep dives into the latest environmental regulations and industrial news, subscribe to our channel and turn on notifications. See you in the next one.